Hello and welcome to another tutorial. So this time we are going to be continuing with the hybrid goal-oriented action planning or GOAP series. So in this video we're going to be focusing on getting support for finding something to interact with and interacting with it. So similar to what the sim style AIs would do, but just being done within the framework of the GOAP system. So as always with the videos in this series, because I know it is quite a long and dense series, so you might be dropping into specific videos for it. So I've tried to make things like that easier to do. So in the description, you will find 3 links in particular. One is a link to the code as it currently is for the start of this tutorial. So if you're wanting to follow along, that code is there. The other link is to the code as it will be at the end of the tutorial. And the final link is to the completed package. So if you're just wanting to dive straight to the package and be getting your hands on that and working with that, then you'll be able to go via that link. So there will also be in the description the usual sort of time codes for different sections if you're wanting to jump to particular areas. So with that, let's dive on in. So I'm in our test scene for the sim style AI. So we've got already our interactable objects, things like if that's set up. We've got our smart object manager that is wrangling all of those. We have our game debugger present as well. So what I'm going to do is I'm going to bring in our base prefab. And I will rename this to Sims variant. Actually rename this one because it ended up getting variant added into it, which is not really what I want. So in terms of the behaviors for this, so these are ones that I'm going to set up at this sample level. So some of the stuff I have put at the base level, and likely some of these things I will end up moving into the base level, potentially some of the stuff like Wander and all. The reason they're still at the sample level is because things like this navigation interface is still at that sample level. So once I do more refactoring and I want to then have a lot of these base behaviors like wander and idle and look at actually move into that core set. So that's going to be changes that I end up making after this series as I refactor things like the sensor system and so forth. So there is changes like that that I do have planned. But for now, what I want to have is we're going to have GOAP goal, and this is going to be for using an interactable. So use interactable. So that's good. So I'm going to set up the logic for it first in the goal because there's very little to it. So we follow a similar process to what we normally do. That's a GOAP goal base. Now with this, we need to actually have the priority being driven externally. So this is one of the first ones where we're sort of doing this, where the priority can vary and we have something external driving it. So what I'm going to do is I'm going to create a Unity event. And this is going to be one that will take in a game object so that we can identify who's actually making this request. It's not something that's a factor at this point, but if we wanted to make it be a factor later on, then we easily could. So a bunch of the things I'm doing with the interfaces here are for really trying to give us future flexibility. So this is then going to, similar to what we did with the navigation side of things, our Unity event is going to be passed in a system.action that takes a float. then we'll use that to be able to actually set our desire. So this is going to be get use interactable desire. So that's good. Then we set up our interfaces, which we can just actually tell it to implement it. So prepare for planning. Well, that needs to get our interact desire. So interact desire. Now initially I'm going to set that to float min value. Then what I would do is invoke this function. Now I want to provide the game object. So that's something where the game object is ourselves. Now if we go to the goal base, I don't know if we've got this set up yet. We don't. So we don't have, we did set up some stuff for like getting an owner and things like of that. What I'm going to do is have, and I might make it protected for now, a game object, and we're going to call this self. And what that's going to do is do a linked Blackboard, get game object, and we can retrieve the self key like that. And I might actually put that into the action base as well, because I think that's a really handy thing to have support for. That's good. Now, in terms of what this is going to do, it's going to invoke it with self, and then it's going to need this system.action function. So in desire, and what that's going to do is that's just going to run a little bit of code here that will set interact desire, not plus equals, like that. So that gives us a float that should be between 0 and 1. Now, if that interact desire is less than or equal to 0, I'm going to set the priority to say that we don't run. Otherwise, the priority is going to need to be calculated. So the priority, well, we want to do a loop from, now in this case, I think we can go from low up to probably high, I think is fine, using the interact desire. And then we need to floor this to an integer, like that. So that's good. We have the priority being calculated, and that's going to need to link to something that is giving us back that priority, which that essentially, there's a couple of ways we could go about doing that. What I would actually do for setting that up is put that in the rain wrapper. So I might actually put a little bit of commenting here, or use region markings, navigation helpers. That applies to all of those. This region is awareness helpers. Then we have our point of interest helpers. Good. That just makes it a little bit cleaner and neater for we can start to then collapse these, makes it just a little bit neater. So we'll have a region here for interactable helpers, like that. What's this? Cool. So in terms of what we have here, we want something that can get the desire for being able to interact, and that needs to be something that can hook up to this Unity event. So these will correspond to the parameters that it needs to have. So we're going to have a public void get use interactable desire, and this is going to be in query, and this is going to be our callback function. Now, I'm not going to do anything complicated for this. I'm just going to have it be a flat desire. That's something where, with the SimStyle AI, we could be starting to look at the various needs aspects like of that. Same for when we're selecting the interactable. That's something that we could be looking at those aspects for. But that gives us, we can connect up our goal. So we'll have our GOAP goal like that. Now we link this up to the brain. Say is in our GOAP brain wrapper, get use interactable desire. So having to manually link up the events like this is something that I do want to change at a later point, and it is something that I do have some plans for, unsurprisingly involving the FastName system as a way to make that a lot easier and remove manual sort of linking up of stuff there. So now I can set up my GOAP action for using of the interactable. Good. Let's get this set up. So this again is based off of our FSM 1. Get rid of our start and update, and we can tell it to implement all of the different things. So let's get the easy ones done. Supported goal types. We will have this be, as always, our new system type and type of GOAP goal use interactable, like that. That's good. The cost, again, like we did with the other ones, I want this to be just a fixed, fairly low cost. Dynamic costs get a little bit messy, and you want to be fairly careful with when you use them. And until you have multiple things that can actually be done, so multiple actions, you're not really getting any sort of benefit from getting that set up. So for now, we just want to have that. Now, get required resources is going to be our pretty standard using the legs and the torso. So that's good. Now, this is going to be doing movement. So the process with working with an interactable is we need to select one. We need to get a navigable location for it to move to. We need to move to it, and then we need to use it. So there's a few stages there that we need to actually perform. But that's straightforward enough. So what I can actually do for this is I'm going to go to our wander action, because this set up for the search range and stopping distance. This is another one that I do want to at some point look at ways of making it so you're not having to duplicate this in the actions. It's only a small amount of lines, but I do still want to improve that. Same with the actual FSM setup stuff. There's a few sort of helper functions that I will add in post this series. I will do a bit of sort of a improvement, overhaul thing, stuff that I didn't really spot until kind of having implemented it all and then coming through and implementing it again. There's, I think, a few ways of making this quite a bit better. So, okay, our first state is for selecting an interactable. Now, with this, we don't have a state currently that can already do this. So I'm going to have a new SM state, and we'll have a select interactable. That. We're going to have a state then for getting the navigable location to move to. So get interactable location. So this one is going to be a fairly familiar one of we have our state for calculating a move location. So this one, we provide our navigation interface, we provide our search range. Now we need a function that is going to get that actual location. So we'll have a get interactable location. That'll be a local function that we set up. And that is pretty much all we actually need for that. So that's good. The state then we have move to. So that's straightforward. That's one that we're already very familiar with, our SM state move to, which gets our navigation and our stopping distance like that. And then finally, we'll have another new one, which will be the actual use logic. So we'll have a use interactable, and that will do linked state machine, add state, new SM state, use interactable, like that. So in terms of transitions between these, we'll have our usual adding of the default transitions that'll happen at the end. And again, this is one of the ones that I think I can, clean out some of that to make it so that there is less setup stuff. But in terms of then, in general, most of these are going to be adding a transition for a success. So SM transition and state status finished. And that will go to our get interactable. So pretty much all of these are going to be the exact sort of same. If it succeeds, it goes to the next one. And that's again one where I think we can make that a much cleaner sort of setup. At the moment, it is very similar, so there is going to be some good room there for being able to clean that up. And we don't need that last one. So that's good. That will handle the switching between those. Now, with this, for getting the actual location, there's a couple of sort of things there that we want to support for that get interactable location. So this is going to be a vector3. Now this is going to follow a fairly similar structure to what we use in a lot of ones where we're grabbing stuff from our set of common names. So I actually want to add in a couple of ones for our interactables here. So I'm going to, probably similar to this, have a set of ones here and interactable. Now, with this, the interactions, there's a couple of different aspects to this, and we don't actually want the game object and the type. The game object and the position. What we want is the smart object, and we want the type there. So because a smart object has, the smart object has interactions. So that's sort of what we want to be able to be linking to. So that looks good. This will change to interactable and smart object. And this will be interactable type. And I think actually interaction works better for those. So I might change that to interaction. I think is a more accurate description of what it is. And we do want to make sure these are getting properly reset. So so these are a bunch of ones that we've got access to, and in our GOAP brain base, we do already do a bunch of initializing and cleaning out. I'm going to, because these are defined at sort of that core level, I'm going to bring these here and make sure they're getting properly reset. So we're going to have a fairly similar set of logic for a bunch of these. So our awareness is just a game object. Our look at is obviously a game object. The interaction one, that is actually a mono behavior. So we'll do that. And then our interaction type. Trying to remember with our interaction type what it actually was. I believe our interaction type was a mono behavior as well. I'll just double check that quickly. So for these, that rather than being just a mono behavior, will actually be specific that it is a smart object. Now we may get some errors here. This will be base interaction. So what we're likely running into is that we don't have those linked in to the hybrid GOAP setup here. So this has Common Core and State Machine, but we need our framework essentials. So that's happy now. We have our Use Interactable that we're setting up that's a bit grumpy, but that's okay. So these gives us our appropriate defaults for those keys and the right types for them. So that's good. So now we can go back to our action for using the interactable. The goal is actually all done. There's nothing further we need for it. But in terms of with the goal, so we follow a fairly similar logic here, and this is again something where I think there's going to be options for how we can actually clean this up in future and remove some of the duplication, because we do follow a very similar logic in a lot of cases. So I think this is something where I would fold it into something in the base action, not even just the FSM action, but in the very base one of, hey, I need a location. Here's the game object key that might be a priority. Here's this that might be a priority, and avoid having to duplicate the code because I'm trying to have the code be as minimal as possible. So in this case, I'm going to attempt to get the smart object interaction, or the smart object. So the smart object interactable SO is going to default to null. Then my linked Blackboard, I want to do a try get common core names and interaction, and we want to get the smart object. We output to that, default of null, not really necessary, but just being extra sure. So if it's valid, then our interactable location is going to be the interactable SO and its interaction point. And we can just return that. So that's good. That gives us pretty much majority of what we need for the action, but we've got these additional states that we need to set up. So let's get these up and running. So the first state that I need to create, and again, these are ones that I think at a later point, I'll be able to move them down into the core logic, but for now, they make most sense to sit at this higher level of the logic. So I'll have Select Interactable and Use Interactable. Good. Let's edit those and let's get these set up. So these are not too onerous in terms of what they need to do, but there is a little bit that is involved, and Visual Studio is doing its thing. So, okay, Select Interactable is going to be the first one that we set up. So that's going to come from our state base, like that. So, okay, this is going to need a way of actually picking an interactable from the list of available ones. So for now, and to keep that separation, I want this to have to be given a system func takes in a game object, and what it is going to return back, and this is where I'll use a tuple for, and I could actually, using in system, I try to avoid using in system just because you get collisions then with random and there's additional stuff you need to work around. That's why you'll notice when I'm writing the code, I usually do system dot for things rather than letting it using in system. So this is going to give back, because there's two things that define a interaction. One is the smart object that you're interacting with, and then the other is the interaction itself. Because a smart object can provide multiple interactions, and it's that pair of them that uniquely defines what the AI is going to do. So this is our Select Interactable. Actually, Select Interaction is probably more correct. Function. And actually rename this because I think that actually makes more sense for the name. I will rename the file in a moment, but for now, just going to do that. So selecting our interaction, that's going to be something that gets passed in. Now, just in case the autocomplete doesn't work as well as I would like it to, which it didn't, not surprising. So we have that being passed in, as we do for all of our ones. We also provide support for giving it a custom name, which we default to null. And we pass that into the base like that. And then very straightforward for what it actually needs to do. So that's good. So, okay, let's look at what the logic is that needs to sort of happen here. For the exit, nothing actually we need to do. The tick, all we're going to do is return the current status. All of the actual logic is going to sit in this on enter. So first thing I want to do is I actually want to reset a couple of things just in case they're currently sort of populated. So in particular, these. So I'm going to, first thing, clear out that there's any interaction that we're trying to do. So we'll take our Blackboard and we'll update that. So we're wiping any current interaction that's trying to happen. Then if our select interaction function is null, we immediately fail. By default, we'll return that we finished because we're assuming that we've managed to select one, but we'll see. So, okay. Attempt to find an interaction. So we have our interaction, and what we would do with that is we run our select interaction function. We need to get self. So this is one where what I would do, self, and we have our get owner Blackboard. Again, this is one where we can probably set up some better interfaces going forward to lessen the amount of stuff that needs to be created here. There is going to be a big pass that I do on that. So, okay, select the interaction function, we pass in our self. So, okay, that's going to give us back, in theory, an interaction. So what we would say is if interaction item 1 is null or item 2 is null, we failed. So it either didn't find a smart object or didn't find a type. I don't think the tuple itself is able to be null, but that's something where if I go on, way to find out is, so tuple is a class, so that does mean it could be null. So for extra safety, I'm going to just check in case it is null. Now I will, even though the logic is predictable of the order, just for clarity, I will do those extra parentheses. So, okay, we know that it is managed to, we've got an interaction, we've got a smart object and a particular interaction to perform with it. So we need to check, okay, can we lock access to this interaction? So what we would do is f our interaction, and we would say item 2. Now this is something where what would actually be better is to pull out of this the interaction. Well, actually, let's go for target SO. So that's going to be our interaction item 1. And then our target interaction is interaction item 2. So then we can check, okay, well, that particular interaction, so our target interaction, can we lock it for ourselves? And if we can't, so if that failed, then we return that we failed. Otherwise, we can actually populate this information. So the final thing we then do here is we would populate target SO and target interaction. So that's good. That gives us our setup here for being able to select an interaction to perform. But that does mean if we go back to our action, this needs a function provided to it. So we actually need to have a function that we can invoke to get that interaction back. And if we take a look at what we used sort of parameter-wise here, what that means, if I grab this, is we need something in our code that matches this pattern. So we're going to have down here a thing that's going to select the interaction. So what this will do is this will be returns a system tuple. And this is going to be our select interaction function that takes in our query like that. Now I'm going to provide that here. So select interaction function. So that line is happy. Now this needs to do the actual logic. So this needs to get a smart object. So there needs to be a smart object target SO. There needs to be a base interaction target interaction. So we need to populate those and then return a new system.tuple that has a smart object and a base interaction and that holds those. So we need to be able to retrieve those. So this is where we're going to do the same setup we've done a bunch of times of creating a Unity event. So we'll have a Unity event like this, and that's going to take in a game object. It's going to then have a system.action that is a smart object and a base interaction like that. And this is going to be on select interaction. That's good. So this is following very similar to what we had for the goal. So if we look at our goal for using the interactable, we had this sort of setup. This one's going to be very similar. So what we would do down here is we would say on select interaction, invoke. Now we invoke it providing ourselves. Then we have a smart object in target SO base interaction in target interaction. And then we link that over like this. It's going to be very similar logic to what we've done in many different places. So that's good. That is our logic for selecting an interactable. Now it's going to need a function that it actually talks to. So that's something where in the actual brain wrapper, we need to have a bit of logic for selecting an interaction to perform. So as well as this one, we're going to need a public void select, and I'm just going to pick a random interaction. We again have a game object query. Now our callback in this case, system.action again, but it is a smart object and a base interaction. And we have our callback function. So that's good. That will be able to pick a random one. So what we're going to do is loop through all of the registered objects. The Smart Object Manager already has this information. Loop through all of the interactions. So we're going to say for each candidate in our Smart Object Manager instance and our registered ones. So, okay, with this, a candidate will have multiple interactions. This is a candidate SO. So we would then have a candidate interaction in our candidate SO and its actual set of interactions. So this is looping through all of the smart objects. Then we loop through all of the interactions. Now, it's possible that this might not be able to be performed at the moment. So that's all good. If there's the candidate interaction and we cannot perform, we just skip it. Otherwise, we want to track it as a potential candidate. So what I'm going to do is have a list of system.tuple, smart object, base interaction, candidate interactions, and then all we do here is, well, we know we've got this as a valid candidate, so our candidate interactions, we will add a new system tuple, smart object, base interaction, and this is going to take in candidate SO and candidate interaction like that. So, okay, that will build up a list of all of the potential interactions. Now, we might find that there are absolutely none. So, if the count is 0, then, and why is this grumpy at us? Candidate interactions. There we go. Let's make sure that's correct. It is. So if what we get back is 0, so there's none, then we'll run the callback function, providing null, and return. So no interactions. Otherwise, what we'll do is we'll pick a random one. Okay. Our selected index. Well, for starters, if our candidate interactions count is 1, then it's just going to be 0. Otherwise, we'll do a random range from 0 to our candidate interactions dot count. So we've picked a random one, and all we would do is run our callback function, and we provide candidate interactions, selected index, item 1, and exact same thing, candidate interactions, selected index, and our item 2. So that's good. That will be able to pick a random interaction. Now, we won't be able to link up our action yet because we've still got to make our use logic work. So that's okay. We've selected an interaction, however, and we've populated the key bits for that. But now let's sort out our using of the interactable. So again, we clear out all of this logic, we set up our state base, and we'll tell it to implement everything like that. So that's good. Now there's a little bit of stuff that we need to be getting set up here for this. I will just create a very simple constructor for this. So this is our Use Interactable. So we just want to make sure we're supporting passing in that custom name. Because there's nothing else, I'll just keep it on a single line. So, okay, now this actually has a little bit more that we need to be keeping track of because the interactions are a little bit more complicated. So I'm going to have a bool, the has finished interaction, which I'll default to false. So, okay, our tick is pretty straightforward. We would return if we have finished the interaction, then we return finished. Otherwise, we are running. So that's good. Our exit should reset the smart object interaction, things like of that. So that logic that we were doing here, I'm going to also bring this over to our Use Interactable. So the idea is that we are resetting the state of things when we're done so that we don't have old or stray data being kept there in the Blackboard, that the Blackboard is reflective of the current state of things. So I'm going to force has finished interaction to false. So we're resetting that. Then I want to check, okay, well, can I get that smart object to interact with? So target SO, which I'll default to null. We'll do our attempting to retrieve it. So what I want to do is same logic and our interaction smart object like that. Strictly not necessary providing that default of null, but I like to just be very specific with it to make sure it's very clear what's happening. So if that target SO is null, well, we have to fail out because there's nothing we can do. And then when it exits, it will go and clear things out. We also then want to retrieve the interaction, and that should follow the same sort of logic. So we have our target interaction. We will try to retrieve that again. Type. So that's good. Now again, if that is null, then we can't continue. So that's good. We've handled those main cases. Our default is actually going to be to return that we're running. Now, what we need to do is, okay, we've got our interaction. We know that the smart object is valid. All of those bits are actually correct. So what I would be doing is our target interaction, I can tell it to perform, and I need to give it the performance. So we get self by getting the owner of the Blackboard. So we say self. Now this takes a callback for when it's completed. So what I would say is with that callback, interaction, so when it's completed, we'll set has finished to true. And what I will do is that interaction, I will unlock it like that. So keeps it fairly self-contained, allows it to automatically complete itself. It's why in the tick we don't need to actually poll things. So we remove the need for regularly polling the state of stuff, and it's able to just actually handle cleaning up its own logic. So that's good. Now, if we go and check here, our Use Interactable, that we might have made that, should have been null. That should make it happy. So we've got no errors. So what we can do now is we can actually link up that action. Now it's not going to be ready for us to run just yet. We've checked that's correct. we need to link up to our brain wrapper. So this is our GOAP brain wrapper and select random interaction. So that looks good. I'm going to create this as a new variant and fix up the name of it like that. So that's good. We've got all of that connected up. Okay, that's most of what we need for this. Certainly our select and use is all good and all correct. We've got everything populated there in the brain wrapper. But there is a couple of things that if we just had it with this logic, there's areas where it might not unlock the interaction, if the state machine has failed out, things like of that. So there's a couple of little bits of sort of cleanup and extra logic we want to add in. The other thing is our point of interest thing here. We've got another thing that we could potentially be looking at. So if we're trying to perform an interaction, then we want to have it as a potential sort of priority. So the next priority is our interaction target. So something that's a hostile target is still sort of the first priority, but otherwise we have the interaction one as the next point. So we would have in this case, not a game object. This would be a smart object, current interaction SO. So we would take our current Blackboard and we would try to get Common Core names and our interaction smart object. Do the same logic we do with these. Now F, point of interest, is valid for the current interaction smart object. So with that, I'm going to need to go game object. So what I have to check here first is current interaction smart object is not null before I check the point of interest. That way then, if it was null, it won't go and run this. So we're only going to validate the point of interest if it's actually going to be present. So if there's a smart object, then we retrieve the game object associated with it. So if that's the case, then we return current interaction SO game object via the callback and return. So that's good. That's going to clear that out. So that's great. Okay, good for on the brain wrapper side of things for being able to pick what to be looking at. Now, with the actual use side, there is a couple of things we want to do to ensure that stuff is properly cleaned up. And so this is where, for the first time, we're actually going to override some of the logic in the state machine that we haven't previously. So one of the things we can override is override. And we have this state machine reset function. So I want to, with this, if we've reset the state machine, so if it's been interrupted and we still have an interaction, then I want to actually clear that out. So what I would be doing is similar logic to this. So we're going to try to retrieve the smart object that we already have. And if we have that smart object, then what I can do is I can clean that up. So if the interactable smart object is not null, well, then I want to also get the interaction, because the interaction also might not be valid. So we want to have a base interaction, and we'll call this target interaction. I'll actually rename that to target SO just for consistency. So if our target interaction, we'll do the same sort of thing. We will get the linked Blackboard. We'll try to get our common core and our names and our interaction type. And out, target interaction, and null. So if that's valid. So if our target interaction is not null, it's a weird autocomplete choice that it made there. Seems to get a little confused at times. So if we have a valid target interaction, then what I want to do is unlock that interaction, and we unlock it for ourselves. And then the final thing that I will do is what we have done in a couple of spots of clearing out those keys. So we go to our action. So what we will do, just as a thing that it always does when it resets, again, this is probably being a little overcautious, but I think it's good to make sure we're making certain the state is predictable. So that's good. That should mean that it properly resets everything, and it should be able to go and interact and use things. So let's find out. We've got all of this set up. It's got the particular goals, priorities, everything like that there. I don't think there's anything extra we need to set up. So let's save this and go to run it. So it's picked an interaction. You can see that it's turned on the TV. It's now heading over and interacting with the microwave. It's done that. So it's moving and doing all of our interactions. So we have our Sims variant going and performing that basic logic. So that's selecting an interactable, that is moving to it, using it. We're not doing the full complexity of the Sim style for prioritizing, particular needs and wants, because these don't have that. But it is able to go and select and interact with things. Now, as I mentioned, at the moment, a lot of this is happening at the samples layer, but future things that I want to be doing are creating sort of more generic interfaces like I did for the navigation, creating ones for interaction, for looking at things, and then that'll get rolled through in a later update to the project. So we've got our Sims 1 up and running. Now in terms of the code for the project, as mentioned, you will find a bunch of links related to the code in the description. One of those is to the code as it was at the start of this tutorial video. The other is as it was at this current point now. And there is a link to the completed package as well. So there's not too much in the way of behaviors left to implement. The remaining ones are focused on resource gathering and being able to return home. So you'll be able to see those videos soon. If you're watching this sort of just as it's come out, that video will be out next week. If you're watching this far in the future from that, then good news, that video is already available. So if you have found the video interesting and helpful, do chuck in a like and subscribe. Really helps out. It's really appreciated. If you have any questions, chuck those in a comment below. And if you were looking for other ways to support the channel, then I do have a Patreon, and there is a link to that in the description as well. But until next time, bye.